That's benzoic acid, okay? There is heat produced by the benzoic acid that you had to add to your pellet to get it to burn cleanly, if you did. Some people have had to do that, some haven't. So you may have to add that term or you may not, depending. But what you want is Q food. And that's for the dried food, dried ground food in your pellet. What you really want there is the enthalpy of combustion of the food, the dried food in that pellet, which is the negative of Q divided by the mass of the food. Now, if you have only food in your pellet, no benzoic acid, that becomes the mass of the whole pellet. If you've got a mixture of benzoic acid and food, you use the actual mass of food in the pellet to get that. But this is dried ground food. Put the water back into it. You've got the original mass and the dried mass. Figure out the mass of food after the water is removed, actually the fraction of the food after the water is removed, and multiply this and you'll get the energy produced for your original food. You've got to deal with the masses involved. This was a tiny fraction of that. So you need this ratio between the original and the dried to, in essence, conceptually add the water back in. Then you've got to worry about the masses. You can do simply a comparison, cross-multiply to get the mass of your pellet out of this. What fraction of the total dried food was your pellet? Put the water back in, and when you've done that, you've got delta H per gram of your original food as you brought it into me. Now you've got to work backwards for the serving size. What mass did you dry? Maybe you dried 4 grams. What's the serving size? Look on the label. Serving, let's say it was 40 grams. Your 4 grams that you dried was 10% of a serving. So delta H of your food that you brought in and dried is 10% of delta H per serving. What you need to tell me at the end is the energy produced by combustion, which should also be the energy available by digestion and, oh, what's the word? For your mitochondria do their thing. Should be the same as that per serving. You're measuring it for a tiny quantity of a serving, roughly 1 gram of dried food, which is probably something on the order of 2 or 3% of a serving. So you've got to work backwards from this through the drying process to conceptually put the water back in. You've got to worry about the mass here versus the mass there to get the energy per mass of the original food. And then you take the mass of the original food that you brought in to dry relative to a serving size to get the energy available in a serving of food. That's the point of the experiment. How many calories are you going to get by consuming 1 serving of this food? That's what you're measuring. Questions?